Take two.
This is my audience. Ever wondered how music can sound so pleasant to your ear, or why musicians and composers like Lady Gaga or Beethoven have written music that is playable and is so well written? The answer to this is something you may not associate with music: math. Music, even though it is mainly viewed as an art, is deeply rooted with mathematics, and without it, music wouldn't have structure and musicality with how it sounds. Today, I'll be educating about how math is used in music through rhythm, sound waves, and composition. So, how exactly is math used in how music sounds? Well, I'll inform you how. Sound waves are heavily influenced by math. In a simple way, sound is vibrating air. When something makes a sound, like a drum, it causes air molecules to be pushed together, but then pulls them apart from each other. A really good example of this is a slinky. If you're at one end of a slinky and push it, a wave will move through the slinky, but the rest of the slinky doesn't exactly travel the whole distance. A good way that math represents sound is through sine waves. So, what exactly is a sine wave? Well, it's a wavy curve that repeats over and over. A sine wave has three important aspects to it: amplitude, frequency, and phase. Amplitude is the loudness of a sound. A bigger wave means a louder sound. Frequency is what controls the pitch of a sound, meaning if a sound is lower or higher. Hertz is what is measured in. For example, a frequency that is 440 hertz is the note A, which is actually often used to tone instruments. The next part is phase. Phase is where the cycle sounds and starts. Phase describes how much one sine wave is shifted relative to another. Sine waves that are perfectly aligned to peak are called in phase. Music is made up of sine waves that are combined together. Now, I will talk about how rhythm works in music. Math is the reason why music has different rhythms in music. For instance, the time signature for a piece is 4/4, which is able to be simplified into 4 beats per measure. A measure in music is a unit of time which is defined by the given number of beats. So, for example, in a 4/4 time signature, you would consequently count it 1, 2, 3, 4. You're probably now wondering where the math comes in. The beats in the measure are able to be subdivided into smaller fractions, creating rhythmic patterns that follow mathematical sequences. Polyrhythms are another example of how math is used in music. They are pretty much just two different rhythms playing at the same time. A good way they are represented is through ratios like 3:2 or 4:3. Polyrhythms also break beats into smaller fractions. If a full measure is a one whole note, for example, you can play triplets while the other plays quarter notes. The complex idea of this creates similar patterns similar to number sequences. Picture two different people clapping simultaneously, but they're clapping at different rhythms. This technique is very popular in pop, techno beat songs, and classical music, which helps songs not appear to sound repetitive. Now, what do I use with all this knowledge about how rhythm works in music? Well, you can use it for how to compose music. In order for a composition to be successful in music, math needs to be a key component in it. When you combine rhythms, harmonies, and wavelengths, you get to composing music. Since we already know patterns are purposely created by using math, but do you know what this is? Well, doing these patterns can turn into music scores and sheet music due to the structure. Another quite common technique in composition is repetition. This technology is simply just multiplying a phrase or more by a factor. In music terms, it repeats the same set of chords or notes to create a pattern. A good example is the popular piece Clair de Lune by Claude Debussy. He uses repeating melodic and harmonic chords and rhythms. This is good proof that mathematics can create beautiful pieces, even though there is logic and structure used. Composers will also use transformation in their compositions, like translation. In math, translations mean moving left to right and up or down. It shifts the melody up or down in pitch. Another way math is used in composition in music would be inversion, meaning it will mirror the melody over a pitch. In a mathematical way, it would be a reflection across the x or y axis. So, conclusion. In conclusion, all of these techniques and other mathematical concepts put together is what makes music composition work. Simply, math is a tool that composers use to create new music. It's what helps organize and shape the music we know and love. So the next time you're listening to your favorite music artist or song, just remember that mathematics is a key reason in why music sounds the way it does.